Example 9, a piece of wire 14 centimeters long, so that'd be this right here, cut into two pieces. One piece is being bent into a circle, the other one is being bent into an equilateral triangle. How should the wire be cut so the total area enclosed is a maximum and a minimum? So we want to find both. So I'm going to cut it somewhere, doesn't matter where. It's a 14 centimeter wire, so let's make one length X, and the other is going to be whatever's left over, which would be 14 minus X. So that's our starting point. I need to make a a circle on an equilateral triangle. I would probably go with the triangle for X and the circle for 14 minus X. But just know that it could be either. All right, equilateral triangle, what's true about the sides of an equilateral triangle? They're all the same, right? So what X represents is the length of the perimeter of that triangle, right? So if we bend that into an equilateral triangle, so if I were to draw an equilateral triangle, that's my ability here. It's pretty good. And the perimeter of that equilateral triangle is X, then each side is going to be X over 3. And if we consider the circle being created out of this other piece, the circumference of that circle would be the length of the wire being formed, that's being used to form it. So I would know that the circumference of this is 14 minus X. And we know circumference is 2 pi r, right? That makes the radius equal to 14 minus X over 2 pi. And so if we just really focus on important dimensions here, that helps us to establish, hopefully, something about the area. Now, one other thing we know about equilateral triangles is that the angles are 60 degrees. Alright, so as far as finding the area of a triangle, we've got several formulas we've learned through the years. We've got the 1/2 base times height. That doesn't work well on this one because we don't know what the height is. We did learn in Algebra 2 how to find the area of an isosceles triangle, which an equilateral triangle would have the same property since it has equal sides here. You draw the height down, cuts the base in half, Pythagorean theorem gets you the height. Then you got your 1/2 base height. In trigonometry, we learned Hero's formula. The perimeter divided by 2 is S. And 1/2, the square root of S times S minus each side is the area. The other formula we learned would be much more easy than that. In this case, is 1/2 times A times B times sine of C. So if I look at the area of the triangle, it's going to be 1/2 times leg, or times side times sine of the included angle. So I don't know if you guys recall that formula or not, but in general, anytime you learn formulas, if you remember them, it's a good idea. So that formula is the easiest one to get the area for this triangle. Sine of 60 is equal to the square root of 3 over 2. So just like that, we get the area of the triangle is going to be square root of 3 x squared over 2, 4, 36. The area of the circle is going to be pi times the radius squared. So the circle's area is going to be, let's see, 14 minus x squared is 196 minus 28x plus x squared. That's being multiplied by pi, and that's over 4 pi squared. Everything in the parentheses being squared, 2 squared is 4, pi squared, pi squared. This pi cancels that pi, so we end up with the circle's area is going to be x squared minus 28x plus 196 over 4 pi. So the total area enclosed, the area of the triangle and the area of the circle, if I add those two area formulas together, I've got an actual area formula here, right? And as before, I can get an approximation of this, right? So focus on that. Square root of 3 over 36. Comes out to 0.0481. And if we look at this other side, we have everything's divided by 4 pi. So if I do 1 divided by 4 pi, now be careful if I type in 1 divided by 4 pi just like that, it divides by 4 then multiplies by pi. I got to put parentheses around the 4 pi. So the calculator knows that both 4 and pi are in the denominator. So that would be the coefficient of x squared. So the circle formula here, 1 over 4 pi is 0.0796 x squared. We do 28 divided by 4 pi again, divided by parentheses 4 pi, comes out to 2.2282. And then 196 divided by 4 pi comes out to 15.5972. Just like that, we get our area formula as a quadratic function and another quadratic. If we add the two areas together, it's just a matter of adding 0.0481x squared to this 0.0796 x squared. So the total area is going to be, let's see, that's 7 carry the 1, 2 carry the 1, 0.1277 x squared minus 2.2282x plus 15.5972. As with all these problems we've done to this point, that is our goal. Our first goal is to get us to what we're trying to optimize down to a single function. Now if you look at this, it has a part A and a part B. They want the maximum area and the minimum area. All right. Up till now we've had pretty much no intervals of consequence, right? We started at 0 with a parentheses up to infinity usually. All right. This one actually has a specific interval for x. X's smallest value is 0, and x's largest value is 14. If we put that into context about what that means, if x equals 0, that means we don't have a triangle, we only have a circle. If x equals 14, that means we don't have a circle, we don't have a triangle. So we have the ability to make just a triangle or just a circle by zeroing one of those things out, right? So that means we have endpoints. So we have our normal critical numbers that we find, something between 0 and 14 hopefully, but then we also have 0 and 14 as critical numbers. And we're trying to find the absolute maximum, absolute minimum on this given interval. So this takes us back to chapter 4.1, where we had problems where it says find the absolute maximum minimum on an interval. We found the critical numbers including the endpoints. We evaluated the function at each of those numbers. Whichever one was the biggest, and whichever was the smallest was the smallest. Okay, so it kind of simplifies things up a little bit in that sense. If I'm looking at this, as far as finding the critical numbers concerned, obviously 0 and 14 are critical numbers, they're endpoints. Polynomial functions aren't undefined, so we don't have to worry about that. So I basically just have to find out where this thing, this derivative equals 0, so I got to first find the derivative. A prime is going to be 0.2554 x minus 2.2282, set that equal to 0. Move the 2.2282 to the right, divide both sides by 0.2554. That's not to miss a number there. 2.2282, there we go. Right. So we get 8.7244. So I could go ahead and do intervals 0 to 8.7244, 8.7244 to 14, find increase and decreasing like that. But we have a closed interval with a specific critical number on that interval. So if I just evaluate the area at x equals 0, x equals 14, and x equals 8.7244, the biggest area is the maximum, the smallest area is the minimum. Because again, we've got all our critical numbers established here. So all I'm going to do at this point is do What does A of 0 equal? What does A of 14 equal? And finally, what does A of 8.7244 equal? And to find those areas, I simply type the area formula in. So we have 0.1277x squared minus 2.2282x plus 15.5972. All right, go to my table and enter my three numbers that I can't see. Here we go. So I have 0, 14, and 8.7244. So at 0 we get 15.597, so 15.60 if we go a couple decimal places, 9.43, and then we have 5.88. So looking at this, if we make 0 for x, so no triangle, only a circle, we get the maximum area. So for part A, as far as answering this is concerned, it's just a matter of establishing how to cut this wire, right? Part A, maximum occurs if we only do a circle. If we only make a circle. Part B, the minimum occurs when x equals 8.7244. So minimum, maybe I'll put a colon there. We're going to use 8.7244, so 8.72, let's go, centimeters for triangle. And then the leftover, which would be 5.28 centimeters for the circle. Okay, there's going to be a problem like this on your homework. There's an independent practice on the back. Pay attention to these figures you're making out of these. If it says a square, then make a square, each side's x over 4. X over 4 times x over 4 is the area formula for the square. So you're going to be making some sort of a figure. Just make sure that you make the figure correctly. And again, just explain it to me. If I'm the one cutting the wire and bending it, explain to me how I should cut it and bend it to make the minimum maximum occur. And that's what I'm looking for.